Hey, this is Harsh, and today I will be talking about how to write an LLVM pass. For an introduction to LLVM, you can watch my previous video, and now starting with LLVM passes. So, the LLVM pass framework is an important part of the LLVM system, and these LLVM passes provide a structuring technique for the compiler code. These passes are where the most interesting parts of the compiler lie, and these passes perform the transformations and optimizations that are part of the compiler, and they also build the analysis results that are used by these transformations. For the purpose of this demonstration, I will be following this user guide, the writing an LLVM pass from the official LLVM site. And to find this, you just need to type writing an LLVM pass, and you should go to the first link. And clicking on that link opens this page, and this con- this contains almost all the steps that are required to make a new pass work. Some steps related to handling CMake are not mentioned, and we will look into them in this video. In this demo, I am implementing a pass that replaces the add instructions in the input IR with multiplication instruction. This is not in any way a correct transformation, but I am just using and implementing this transformation to describe how to write a pass. From now on, I will use the name add to mul pass for my pass that implements this transformation from addition to multiplication. So for this pass, I have written two files, add to mul.h, the header file, and add to mul.cpp, the file that contains the implementation for this class. So to start with add to mul.h, I have kept this file within the include directory. This is because this is the place where all the header files need to go. And within the include directory, I have kept it in the inst combine directory because in my view, this transformation is most likely similar to a people optimization, and that's why this location is justified in my view. This code is almost similar to the boilerplate code that is readily available for the hello world.h header file from the tutorial that I shared earlier. So I have just replaced the hello world with add to mul wherever needed, and this class add to mul pass, which implements the pass, inherits from the pass info mixin class, which sets up some boilerplate code that we don't want to set up ourselves. For simple passes like this, we only need to declare and implement a single function, the run function, that will be called for each of the functions in the input IR when this pass is run. So this function run takes as input a function and a function analysis manager, and it returns the preserved analysis. This class declaration is contained within a namespace LLVM so that we don't pollute any other namespace in the project. Now moving on to add to mul.cpp, I have kept this file in a new directory add to mul within the transforms directory. LLVM lib transforms is the location where some other passes are also present. So first thing that you need to do is to include the header file corresponding to your pass in this cpp file. After that, you generally also include some other header files that you are going to use in your code. Now this file, the cpp file, should only contain the implementation of the functions that you declared in the add to mul or the corresponding class in your pass. So I have used a variable changed, which tracks whether or not we have replaced any add instruction with a multiplication instruction so far. And just to show that this pass has started running, I am printing in function to the standard error stream. With this for loop, I am iterating over each of the basic blocks in the function, and in the second for loop, I am iterating over each of the instructions within the basic block. And in this line, I am dynamic casting to a binary operator class, which, if not null, proceeds further. Here I check if the instruction is an add instruction. If yes, proceed with this line with these lines below. So Here I am using the IR builder class to build the multiplication instruction that will be replacing the add instruction that we found. And here I am just copying the operands from the add instruction to the multiplication instruction. Finally, we are replacing the add instruction with the multiplication instruction and erasing the add instruction from the parent basic block. After this, we are uh, changed to true to mark that we have replaced a add with a multiplication, and we are printing done transformation to standard error stream. After this, on the basis of the value of changed, we are returning either preserved analysis none or all. After writing the files related to your pass, there are a couple of more steps that you need to do. The first step is to register the pass in the pass registry.def, which is the file located in this location. So here I had to add this single line to register the pass, and the first argument to this macro add to mul will be used for the opt to specify this pass. Other than this, the second step is about passbuilder.cpp file, where you need to include the add to mul.h header here. This is because the pass registry.def is included in this file, which builds our pass together with these passes, and it needs the header here. Other than these, you also need to modify the CMake lists because we have added a directory and we need to uh, make appropriate changes to make it work with these changes. So the first CMake lists that you need to change is in the transforms directory, and you need to add a single line add subdirectory add to mul because we want a subdirectory named add to mul to be created in the build directory. The next CMake that we need to create in this case, because we this is a new directory, and you need to create add these lines to this CMake list because we are creating a new library LLVM add to mul, which will be compiling this add to mul.cpp from this directory. And other than this, you also need to change this CMake list because we are compiling our pass add to mul as part of this LLVM passes library also. So here you need to add this add to mul similar to other directories in the transforms directory like inst combine. This basically says that this LLVM passes library should be linked against lib LLVM add to mul.a. After doing all these changes, you just need to go to your build directory and give the ninja build command there. You can also give ninja opt because we only need the opt or the optimizer for this demonstration. Both of these are fine. I will not compile again because I have already compiled. So I will just move to the tests directory, and here I have a file that has some input IR that will be used as input to our pass. As you can see, it has got a add instruction %8 is equal to add. Let's see how our pass works on this. So I'm using the op tool from my build bin directory. Here the add to mul is specified, add to mul.ll is specified as the input, and output.ll is the uh, output file. And we are specifying add to mul to be run on this input file. As we can see, it has printed in function. That means the pass ran, and it has also printed done transformation. That means add has been replaced with multiplication. Now to see the modified IR, we first need to convert the bitcode file, the bitcode file output.ll to human readable IR format. Now, as you can see, the add instruction has been replaced with a multiplication instruction as shown here. So there you go. There you have the pass that is working now. Remember, we don't need any other steps than the ones mentioned in this video because we are building our pass as part of the LLVM project. So all these steps are sufficient. And to write the code in the C++ files for these passes, you need to look at some other existing passes and learn from there. That's the way to go. And you can also consult the LLVM standard documentation for the various classes and structures that the LLVM project uses. So that's all for this video. Thanks.